Alright, school excursion to watch a musical at the theatre is scheduled to take place next month. However, it will be cancelled if fewer than 20 students sign up for it. So this is just telling us the first condition we need, at least 20 students to sign up. Okay, so necessary condition 1, minimum 20 students. Okay, on top of that, even if 20 students or more sign up, there must be enough teachers to accompany them. Okay, so that's necessary condition number 2, which is enough teachers to accompany them. Okay, and that would be specifically at least 1 per 10. Okay, as per the school's policy. So let's go through the statements. Rohan, as long as 2 teachers are available to accompany the students, the excursion will still go ahead. He's wrong on so many levels. First of all, what if there's 40 students? Then you'll need 4 teachers, right? So we don't know how many students will sign up. What if there's an overwhelming number of students who have signed up, and still, if we had 2 teachers, that would not be sufficient, right? So that would mean necessary condition 2 fails. Also, Rohan is wrong because even if all these conditions were fulfilled, that's still not enough to guarantee that they'll go watch the school excursion. Sorry, they'll go watch the musical, because what if, I don't know, there's a COVID outbreak, or what if there's a protest on that day? You never know what's going to happen, right? And maybe there's some other necessary conditions which are not mentioned in this particular text box. Okay, so Rohan is wrong. Megan, if the excursion is cancelled, it must be because not enough students signed up for it. No, it could be because there were not enough teachers, right? Or it could be due to some other reasons that's not listed in this box. So Megan is also wrong. Whose reasoning is correct? Neither Rohan nor Megan. Okay, moving on. 4 students were comparing how much they enjoyed English, history, and maths. Okay, so let's first read the question, or the main question. What is the maximum number of students who could have liked maths the most? Okay, so we have 4 students. So let's start with Emily. Emily likes maths more than history. So could she like maths the most? Possibly, right? So let's just put a question mark here. I think it's likely. Okay, but we have to keep reading all the rules. Only Gemma liked English more than history. So could Gemma like maths the most? Well, for Gemma, if she likes English more than history, right? Could she like maths the most? No, because if she likes maths the most, that would contradict the last rule that no one liked history the least. So Gemma can't like maths the most. Because she likes maths the most, that would contradict the last rule. So it must be the order of English, history, maths, or English, maths, history. But Gemma can't like maths the most. So Gemma does not like maths the most. Okay, M, yes, she can like maths the most. What about Wesley and Rohit? So Wesley and Rohit both like maths more than English. No one liked history the least. That's still possible for them to like maths the most, because let me show you. What if they liked, in this order, maths, history, and English? Right, so history is less popular than maths, more popular than English, but they both like maths more than English, and they don't like history the least, right? That's the key rule we have to follow. But yeah, it's possible that Wesley and Rohit like maths the most. So what is the maximum number of students who could have liked maths the most? Emily, Wesley, and Rohit, not Gemma. So 3 students maximum. Okay, 28. 5 keys are placed on a glass table. The image below shows a view of the table from above. So this one's a little bit tricky, but you have to understand what's going on and which view you're viewing from. So you're viewing from under the glass table. And the way you can orientate yourself is maybe focus on, just focus on one key first, because it's confusing if you focus on all of them at once. So I'm just going to focus on this key. Okay, so this key, where do I see this key in the options? Well, I see it there, 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 there. It looks to be the longest, and its blade is orientated almost horizontally to the length of the glass table. That makes any sense. So what do you think is the view? The view is actually from, I know it's a bit confusing, but it's from, you're looking from there. Okay, so you're almost turning it upside down. You're turning upside down and you're viewing the bottom from upside down, that orientation. So, okay, this question is a bit overwhelming, but there's easy ways you can quickly work out the answer. First of all, just eliminate based on focusing on specific features. The first feature I notice is that this particular, I would like to call it, I don't know what they're called, notches, or the head. No, that's the head. Let's just call this the notches of the key. It's facing away from the main edge of the table. So we need the notches to be facing away from the edge of that table, the horizontal edge. So for A, that's fine. For B, that's fine. For C, that's fine. That's D, is fine. But then you also have to say the notches are directed towards the width. Okay, so it's pointing towards the width. So for A, that doesn't work because the notches are not pointing towards the width. It's actually pointing all the way towards that other side. So A doesn't work. For B, yes, the notches are pointing towards the width. C, yes, the notches are pointing towards the width, right? Which is what we want. But for D, the notches are pointing all the way towards the other side, so we can eliminate D. Now we're just left between B and C. And if you're really in a hurry, just look at the differences between B and C to save you time. So if you look at B and C, they're pretty similar, but the only difference really between them is that key. So let's focus on that key. Again, very simple. Just look at that key, orientate yourself. What is going on? Well, I would say the tip of the key is pointed towards the width. Okay, so the tip of the key has to be pointed towards the width, which we don't have in option C because rather it's the head of the key that's pointed towards the width, not the tip. We want the tip to be pointed towards the width, which is what we have in option B. Okay, so that's why C is not the answer, B is the answer. That's it. Okay, so I know these questions look very overwhelming, but all you have to do is hone in on small features and just eliminate based on that. Also, you can compare similarities and differences between the answer options themselves to save you time in an exam. Okay. All right. Question 29. When players are dropped from the school football team, it is usually, again, be careful, usually means sometimes, not always, because the coach thinks they have not been playing well enough. Sometimes a player will be dropped for not attending training every week. So there's two possible reasons why players could be dropped from the school football team: if they're not playing well enough, so they're not competent, and if they're not attending training every week. Okay, but there could also be other reasons why they're dropped, right? Maybe they have, I don't know, poor sportsmanship, maybe they're really rude, maybe they've harassed other members, or maybe they have some kind of personal injury, or maybe they have underlying health issues. There could be so many reasons, right? These are two possible explanations for why they dropped. So knowing this, it should be pretty easy to answer this question. Kylie, the coach said she's going to drop Katya even though she's been playing well. She can't have been coming to all the weekly training sessions. Now, Kylie is wrong because Kylie fails to consider other possible explanations, which we talked about earlier. Right? Kylie assumes there's only two possible explanations, so she's committed, well, what we like to call false dichotomy, assuming if it's not A, it must be B, failing to consider other options. So that's a very common fallacy in real life that people commit as well, having really black and white thinking there's only two possible explanations when there could be other ones. So Kylie's wrong. Fiona, if she came to the sessions and started playing even better, the coach definitely won't drop her. Again, she's wrong because we don't know why Katya was dropped, right? Maybe she had an injury, maybe she had a poor attitude, right? These are just possible reasons for dropping the player. And how do we know that once you've been dropped, you can redeem yourself and come back? What if there was a policy where once you've been dropped, you're never allowed to come back, right? So we can't say, oh yeah, if she started improving on these fronts, she'll definitely be accepted back into the school football team. We can't assume that, right? And always be careful of words like definitely or must or can't, because they are all words which assume certainty, right? And you should always just be a bit wary of them, okay? Because it's very easy to disprove these statements. In this case, both Kylie and Fiona are wrong. D. Okay, how do we weaken this argument? So again, you just have to find the main conclusion. The main conclusion is solid glass can actually be better described as a slow-moving liquid. And then the premises, well, the main premise is that the particles move just like in a regular liquid, and they're not fixed in an orderly structure. In glass, this movement is slow, so it cannot be detected during a person's lifetime or even over the course of several generations. Okay, and then one of the examples they've given to support this is medieval window glass, which has survived to the present day and is often found to be thicker at the bottom than at the top. So what they're saying is that if we had glass, the glass is flowing because it's apparently a slow-moving liquid, and therefore the bottom is thicker. So the bottom is thicker than the top. Okay, so this validates that glass is basically liquid, okay? So how do we weaken this argument? Well, we want to show that maybe this example that they've given is very, very flimsy. It doesn't actually prove anything. Maybe it's not that glass is flowing, maybe it's just designed to be like that, right? Maybe medieval window glass just happens to be thicker at the bottom. Maybe it's not necessarily glass flowing that is causing the bottom to be thicker. Perhaps maybe the top is being eroded, or maybe there's some kind of rusting or some kind of weird chemical process happening that's causing this discrepancy between the top and bottom thickness. Or it could just be inherent to the design of medieval window glass. Okay, so we want to weaken the argument. Let's go through the options. A, glass can be melted, and melted glass, like every liquid, flows and obtains a shape. This strengthens, because this is pretty much further proving why glass is basically liquid. B, the human eye cannot detect tiny differences. Okay, well, they already repeated what's stated in the passage. They're not really weakening the argument, right? They've just repeated what's in the passage. So definitely not weakening the argument. C, modern buildings such as skyscrapers are often constructed of glass. That's just irrelevant. That's not telling us anything about if glass is like liquid. D, glass objects from ancient Egypt or Greece which have remained untouched for millennia, so that's 1,000 years, are not thicker at the bottom than at the top. That's very good, because that shows us that not all glass are thicker at the bottom than at the top. So that kind of calls into question the validity of the example they've given here, right? Is it actually that glass is flowing? How do we know that, right? D is a very good option for weakening this argument. Alright, Alice is having some fun typing dates into her calendar. She types them in the format DD, so day, month, year. Okay, so 7th of March 1996. When she enters the date 12 February 2021, she notices that it reads the same date when she turns it upside down. Okay, so, yeah, I think you guys know what 12th of February would look like. It would just look like that. And then if you were to turn it upside down, oh, okay, so try to basically reflect this. So if you were to reflect this upside down, I'm just going to use a different color, you'll get 1, and then the 2 reflects upside down will look the same. Okay? And after you reflect it upside down, you want to write it backwards. So that's what it would be when you turn the calculator upside down. First of all, a vertical reflection, and then you want to write it backwards. And when you write this backwards, it would still be the same because it's a palindrome. So there's 2 processes for working out what a date will look like when you turn the calculator upside down. Alternatively, this is probably very long-winded. I'm just going to finish this. As you can see, it's going to just look identical whatsoever. I think you should just write out the date and then turn the piece of paper upside down, okay? So, if we have option A, 19th of January, 10:06, that would just look like 19th of January, 10:06:1. Now, I don't know how to turn this upside down on the computer, but you guys can maybe turn your head 180 degrees and try to see what it looks like. It should also read 19:01, 10:06:1, okay? But if you want to do it manually, instead of turning the paper upside down, which I would advise because it would save a lot of time, the way you would do it is what we've done here. two-step process. First of all, reflect vertically, and then you have to write backwards. But that's just really long-winded, right? Because there's two steps. So up to you. If you reflect vertically, you'll get, this is taking a long time, you'll get 16011091, and then after you write it backwards, you'll get 19011061, which is pretty much what we want for the date to read the exact same as it was upside down. So A is our answer. Okay, just turn your head or turn the paper. That's the easiest way to do it. Don't bother with this process that I've suggested. It takes a bit too long. I know some kids might have been tricked and they might have thought, oh, I have to find the palindrome. That's why they gave you the example 12th of February 2021, because they want to trick you. They want you to think, oh, it's just simply find the palindrome, but really it's actually about which one date will look the same when the calculator is turned upside down. So it's not just about palindromes, right? This is not a palindrome, but this will look identical when you turn the date upside down. Try it for yourself on a scrap piece of paper if you don't believe me, but yeah, that's how you solve this question, okay? Question 32. So for this one, draw a diagram. Okay, it's almost like a spatial reasoning question. So I always say when you have 6 people in a circle, just draw a circle and then just draw 3 lines. 3 lines like this to divide it into 6 equal sections. Okay, so the first person you put down in the circle doesn't really matter, but everyone else you have to be conscious of their position. So Grace is to the left of Catherine. So let's just say Catherine is here, then Grace is here, okay? So Grace is left of Catherine and is opposite of Willow. So Grace is opposite of Willow. So Willow has to be here. Max is facing Kari and is standing next to Catherine. So Max must be here because there's no more space next to Catherine. So Max is here next to Catherine and facing Kari. So Kari must be here. And that leaves us with Liam here. Okay? So they've been playing a game in which they throw a beanbag to one another in a specific pattern. So basically it's firstly you throw to the person opposite and then you hand it to the left. Okay, so opposite, left, that's the pattern. In the first round, after 3 repetitions of this pattern, Willow is holding the beanbag. So Willow is holding the beanbag. Now, the question is, who was holding the beanbag at the start? So we know what happens after 3 rounds. So we have to actually work backwards. So how do we work backwards? Well, we have to do the reverse of opposite plus left. So that's going to be, you have to go right and opposite. Okay, so we want to reverse what's happening. So we want to do 3 repetitions. Okay, so to go backwards. So we want to go to the right, then opposite, so that's with Catherine. So that's 1 round. To the right, and then opposite, so now it's with Kari. That's the next round. And then we want to go to the right, and then opposite, so now it's with Willow. So basically, who was holding the beanbag at the start? Willow, right? Willow. Okay, so back to where it started. All right, option C. So just work backwards. Do 3 rounds of giving it to the right person and then going opposite. Question 33. So what is a mistake Mr. Stead has made? Matt and Yash play chess together every day at lunch. They are at around the same level and they have each won around, so the key word here is around, half of the matches they played. Okay, so Mr. Stead says, I can't remember how many games Matt and Yash played last week, but I know Matt won 5. So they must have played about 10 games. Well, the mistake obviously lies in the fact that he assumes that they have definitely won 10 games, assuming that they always win around half the matches they played. But this is around, so this is saying on average. There can sometimes be outliers, there can be discrepancies, there can be days where, or a week where one player just happens to be doing a lot better, right? Maybe Matt or Yash, they're fluking one week. So the mistake that Mr. Stead has made is assuming that a trend or what Matt and Yash win on average will always appear every week, right? When there can be changes, there can be fluctuations in who wins and who loses.